Hi guys, this is a quick review of density. I'm going to introduce a new concept as well that fits with density that you might be familiar with. Basically, density is mass divided by volume. But what does that mean? Well, it's a ratio of how much mass fits in a certain amount of volume. So if I take 1 centimeter cubed of space out of any material in the world, I can tell how many grams of mass are going to be in it based on what it is. That's because density is a characteristic property. Let's say I have some foam. All the foam that's made of the same material, all that foam, would have a density of 0.03 grams per centimeter cubed. Every centimeter cubed of foam in the world has 0.03 grams stuffed into it. And that's because the particles that make up that foam aren't very attracted to each other. So even in the solid state, they tend to be spread apart from one another. So your density really is related to how attracted to each other the particles that make you up are. Diamond, by comparison, has particles that are pretty crammed together. They're attracted to each other fairly strongly. So the same amount of space of diamond, a cubic centimeter of diamond, has way more particles in it. Iron, even more. Any iron in the world, if I take 1 centimeter cubed of it, will have the same mass. It'll always weigh 7.8 grams. Okay, so that's the concept of density. You also have to be able to calculate with it, though. So how do we calculate density? Well, it's a formula, right? Density equals mass divided by volume. And some students have difficulty rearranging this formula to solve for mass and volume. If you're an algebra student, you might not have too much difficulty. I, for example, can just rearrange this formula by doing this, by putting density over 1 and cross-multiplying so that I can change what I have equal to what. When I do that, I get density times volume equals mass. So now I have a formula for mass. And I can divide both sides of my equation by density to get volume. So volume equals mass divided by density. So I can have all three formulas just by knowing the one formula. If that's not working for you, if you have trouble doing that, all that cross-multiplying and putting things over 1 confuses you, you might want to try this triangle thing. If you memorize this triangle, you can figure out all 3 formulas using it. All you have to do is pick a variable, so let's start with mass. The other 2 variables are equal to it, so this tells us that mass is equal to density times volume. How do I know that it's times? Well, I know that it's times because they're next to each other. So let's pick a different variable. Let's say I want to know what volume is equal to. Well, volume is equal to mass divided by density. How do I know that? Because of this little line between them. That tells me that mass is on top, density is on the bottom. And finally, if I want to know density, I can see that density is equal to mass on top, volume on the bottom. Doesn't matter to me what method you use to know all 3 formulas, but you need all 3 formulas in order to do the word problems that are assigned to you. What I'm about to discuss now doesn't show up really on your worksheet, but is an important thing to understand. We did use density to separate substances. We used it to do flotation, and that's because things that are less dense than water will float on the surface of water, and things that are more dense than water will sink. What causes floating and sinking is something called the buoyant force, or buoyancy. If something is buoyant, it means that it's able to be pushed up by the fluid particles that it's sitting in. You don't realize it, but right now you are actually standing in a sea of air, and those air particles are pressing on you with air pressure from all different directions. And in a way, if you think about it, the ones that happen to be pushing upwards are trying to lift you. They're just not able to do it because gravity has a greater pull on you. The force of gravity on your weight is greater than the force of the particles of air that are trying to lift you up against gravity. But they're there, and they are pushing on you. When you go into water, some of you, depending on your particular body type, may find that that balance shifts. All of a sudden, now there is enough pressure from the particles that are surrounding you to hold you up against gravity. That's certainly true for me. I float very easily. My husband, on the other hand, has to tread water like a madman to keep up with me. So when I get into water, the particles of the water are colliding with me all the time. They push against my body, and they actually have enough force to hold me up against gravity. And that has to do with my density. I am less dense than the surrounding water, and so the water is actually more forceful than gravity is. It's able to push up against me. So really, when something floats, it's because the particles of the fluid that it's in, and that fluid could be air or water or any liquid or any gas, are able to hold it up against gravity. Things do float in air. Think of a helium balloon. Helium is a very, very light gas, and it's not very dense. The particles of helium gas are far, far apart from each other. So a balloon filled with helium has very few particles in it, so gravity doesn't pull very much on it. And the buoyant force of the air surrounding it can push against it and lift it up against gravity. Okay, last but not least, I just want to mention that the density of something affects how it floats, and it also affects how well it floats. If something is floating in water, like these are 3 different pieces of wood, let's pretend. This one has a very, very low density of 0.1 gram per centimeter cubed. What that means is that most of it is above the waterline. Only about 1/10 of it is below the waterline. Here, when the density is 0.5, which is half the density of water, because water has a density of exactly 1, the cube is floating exactly halfway, because half of it is below water, half is above. And if its density is approaching that of water, now it's 0.9, well now 9/10 of it is sinking and 1/10 of it is floating above water. If this object was more dense than water, if it had a density of, say, 1.02, then it would sink down and hang out on the bottom. It would have no choice because the force of gravity would outcompete the force of buoyancy. And that's it for the quick density review. See you guys in class. Okay, finally, I don't want to scare you, but remember all that factor label stuff that we worked on, and I kept making you do it over and over and over again? Well, you're going to need that to work with density, because sometimes I will give you the units in one form, and I want you to change it into another. For example, if I tell you that you have something that has a mass of 75 grams, and I tell you that you have a volume of 0.36 liters, but I want to know the density in grams per centimeter cubed, well, you don't have centimeters cubed for your volume, so you're going to have to convert liters to centimeters cubed. So let's review how to do that right here. Okay, here's the units I'm trying to change. 0.36 liters, I need to get to centimeters cubed. Well, I know that a centimeter cubed is the same thing as a milliliter. You should know that, right? 1 centimeter cubed is a milliliter. So I can just convert to milliliters. So I want to get rid of liters and go to milliliters. How many milliliters are in a liter? 1,000. Have to know that in order to do this. So now I can just multiply by 1,000, and when I multiply 0.36 by 1,000, what do I get? 360 milliliters. Now I can use this number. If I want to, I can convert it to 360 centimeters cubed, because they're the same thing. And I can use that to find my density. So I would go back and plug that in as my volume. But you always want to make sure that you do this, because if you don't, you're going to wind up getting only partial credit on the answer to your problem. And that's my review of density. See you guys in class.